Hi everyone and welcome to another episode of The Guild. So here we are doing some offsets. This one's just a simple one pipe offset. We're going to look at a simple formula, and once you get this down, it will be the base for all the other offsets that we'll be doing. And we'll also be talking about the rule of triangle. Thanks very much. All right, everybody, so here we are with this short video on offsets. You'll see as we work through it that it's pretty straightforward. It's a single pipe, 45-degree offset with one calculation and a couple little tricky things at the end. We're going to consider this to be welded pipe, so we won't worry about screwed fitting allowances and stuff like that. But we will talk about what we need to be aware of with welded fittings. Okay, so let's get started. So here we are with a single pipe offset. And so here's the diagram, and you can see here that we have a run of pipe running this way, and then it runs on a offset 45 degrees and then comes out flat here. Okay, so pretty straightforward, like I said. So what we need to do is we need to establish the center lines. And so you can draw this on the diagram, or you can actually draw this on the floor if you're doing layout. One thing to notice here too is that if this dotted line, if you move it to the edge here of this pipe and go to the edge of this pipe, you'll get the same measurement. Or you can go outside of this pipe to the inside of this pipe, and it will be the same measurement. I like to keep them in the centers because it helps me remember one important thing as we get closer to the end. With the center line drawn through the offset portion, you can see here that we actually create a triangle, a right angle triangle, and there's a certain rule with triangles that I'll highlight in just a second. But you can see here that my center points are actually in the center of the fittings. Okay, and so we're going to need to remember to take the fitting allowances off of these 45s to get the true measurement of this piece here. So if we're out in the field and we need to cut a piece of pipe for a welded application, I need to know the length of this pipe. So when we get to the rule of triangles, in this simple approach to trigonometry and triangles, one of the key things to remember, especially when you're dealing with a 45-degree offset, and just to highlight for those of us that don't remember or may not even know, triangles consist of three angles, hence the word triangle, three angles, and all three angles must add up to 180 degrees. And so this symbol in the bottom right-hand corner represents that this is a 90-degree angle, meaning that is 90 degrees. Now that must mean that these two share the other 90 degrees. And so in a straightforward offset that we're going to be doing today, we're going to assume that both of these angles are 45 degrees. They don't have to be out in the field or on paper or in theory. They don't have to be the same. But we're going to say that at least one of these angles is 45 degrees. That way it kind of defaults us to this small calculation here. So you can see here the travel or offset times 1.414 equals the hypotenuse. So what we mean by that is the travel in this case is running from left to right, and the offset in this case is moving from this point up to here. So what we're saying is if we know one of these two measurements, the travel or the offset, then we can determine what the hypotenuse is by simply plugging it into this equation. Okay. So when we move forward now, I can put that triangle, just for visualization's sake, into our picture here, and will help us to understand that my travel is on the side where the pipe just continues to run in a straight direction. Okay, and the offset is always the distance between the two center lines. So whichever way you want to remember that is cool for me. Just if you can remember one, the other one just ends up being a default location, and you just fill it in. And on the other side of the triangle is called the hypotenuse, and it's always on the opposite side of where the right angle is in the triangle. So having labeled our triangles and knowing the simple formula of offset or travel times 1.414, we can approach the mathematical portion of this little problem before us. So what we need to know is we need to know a dimension. And so in this case, we're saying the dimension between this center line and this center line is 3 feet or 36 inches or 914 millimeters. Now, the reason why I'm saying or is that 3 feet translates into 36 inches. I think all of us understand that. But 3 feet also translates into 914 millimeters. And because you'll know that 1 meter or 1,000 millimeters is a little bit bigger than 3 feet. Actually, it's 3.128 feet. So if I say this is 3 feet and I want to convert it to millimeters, I can go online and look at the conversion rate, or I can start memorizing some of my foot increments in millimeters. And so why would I want to do that? Well, sometimes the drawings are given to us in millimeters, and if we're not used to dealing in millimeters, we're going to have to know how to convert back and forth. And that's an essential skill for most trades. So if we're going to get a drawing in millimeters, and we want to convert it to feet because that's the size of our tape measures, then we're going to have to know what the millimeters equal in feet, and vice versa. Now, it's also interesting to know that we will have to be able to bounce back and forth sometimes because it may just be more accurate for us to use the millimeter or even the inches increment rather than the whole feet. And that may play out a little later as we get into this. So for now, we're just going to say that this distance between the two center lines is 3 feet. So when I go back to the formula of triangles, travel or offset times 1.414 equals the hypotenuse, I follow my formula down, and it says, well, 3 feet times 1.414 is equal to 4.242 feet. Or 36 inches times 1.414 is equal to 50.9 inches. Now, ironically, if I took the 4.24 and multiplied it by 12 inches per foot, I'm going to get the same number, 50.9. And then if I want to go into the millimeters, the 914 you can see here is, when we finish it out, it's 1292. Now, it's not exactly 1292. It's a little bit bigger than that. So you can decide whether you want to round down or round up. Okay, and so for the purposes of exams, and especially for purposes out in the field, you're not going to worry about the 0.9 or the point, even, well, you might worry about the 0.24 because we want to convert that into fractions of a foot, and so we want to know how many inches that would be, and so that way we can mark it out a little easier. But that's why I prefer to do all my stuff in millimeters if I can. The only problem with that is that sometimes you lose numbers in translation. So just be careful when you're approaching this kind of question. So coming back to my drawing now, I know that through my calculation, the distance between this point here and this point here is the 4.24 feet or the 50.9 inches or the 1292 millimeters. Now you have to remember that this is a center-to-center measurement, okay? And that's key because all I want to do is I want to cut this piece of pipe that's in between the fittings. If I just go and cut a piece of pipe at 1292 millimeters, it's going to be too long. And that's going to pose a problem if I'm just the one cutting and now I'm going to hand that piece of pipe over to my fab guys, and they start putting it together, and they may not understand how this piece of pipe fits into the larger context of the piping system. And they're just going to build this piece of pipe and then ship it to me, or they're going to build it in another room and then give it to me. And the problem with is that if they go ahead and just install that piece of pipe at 50.9 inches or 51 inches, whatever you want to call it, it's going to be too long. So then I'm going to have to cut it and then get the welder to re-weld it. And that's just a waste of time and money and effort. Okay. So you have to remember that this is a center to center measurement, and we have to deal with that. So in order to deal with it properly, we're going to use a book called the IPT Pipe Trades Training Manual. And it's put out by Robert Lee. You can purchase these books on your own. For the purposes of copyright, I can't go into the book and show you all the details, but I've done my own little drawing to kind of highlight the information that we need to know. And so what I need to know is the measurement or the distance between what we would call the face of the fitting, which is the welded piece right here, and the center of the fitting, because that's where my measurement begins and ends. So I want to know the distance between those two parts. And so that IPT book is going to tell me that distance based on the size of pipe that I'm using. And so in this case, we're just going to simply be using a 4-inch welded fitting. And so what we need to know is the distance between the two, and in this case it's 2.5 inches. So we're gonna really simplify this down. You could jump a whole bunch of steps here if you're familiar with what you need to do, but I'm going to break it down and deconstruct it into step by step so that we can just walk through each piece at a time. So the next thing to do is to remember that we have 50.9 inches between the two pieces. And so what I need to do is I need to take that 2.5 inches and multiply it by 2. And why do I have to do that? Well, because there's two fittings. And so I have to take two fitting allowance measurements and subtract it from that overall length of 50.9 inches. So when I do that, this is what the formula looks like: 50.9 minus, in brackets, 2.5 times 2, which is really 5 inches. You could just jump ahead and do that. So 50.9 obviously minus 5 is 45.9. But another thing I wanted to point out is you can't forget about the weld gaps. Like I said earlier, this pipe is welded together. And so typical weld gaps are 1/8 of an inch each. And so I'm going to have two weld gaps, one here and one here. And so I have to take those into account too. And so to make it easy on myself, I convert that 1/8 fraction into a decimal. So I simply just take 1 and divide into it 8. Or in my case, I've memorized my 1/8 increments in decimal inches. And so I have to take into account those two gaps that are there. So down here you can see that I've taken that 45.9 and I subtract from it two weld gaps. So therefore it gives me the 45.65 inches. Now, instead of going through all that and doing it step by step by step by step, you could do it all at once and say to yourself, well, okay, this is 5 inches here, and I know that this is going to add up to 1/4 inch. So if I take 5 1/4 inches off of this measurement here, it's going to end me at 45.65. So you can circumvent the number of steps. But again, like I said, to deconstruct it and kind of break down what I'm doing, I'm just doing it step by step for you. So therefore, this piece in the middle is 45.65 inches. Now, I could take that 0.65 and convert it to a fraction of an inch for guys that are using tape measures. I could have done all of this in millimeters if I wanted to. That gets me a little more accurate. But it really just depends what I'm used to working in, what the drawings are sometimes marked in, and what my fab guys and my welders are used to working in. And sometimes if I'm the guy doing the design, layout, and the fabrication with the welder, I'll decide what I'm going to do, and then we'll just use those measurements there. So I hope this helps, and I'll look forward to any of your comments that you may have. And this was one pipe with a simple 45-degree offset. Hey everybody, thanks for tuning in and watching this video. I hope it was valuable to you. If it was, press the like button or press the subscribe button so that way you get all my new videos as soon as they come out. Also, pass the word along that these videos are out there on YouTube. It'd be really awesome if other apprentices and new journeymen knew that these videos were there, just to give them a helping hand. And also remember that there are other videos and other playlists like my productivity skills, essential skills, trade skills, and exam skills. Those things that will help you get ready for that IP exam. So my email address is in the show notes. So is my other social media connections. So why don't you just go ahead and get in touch with me. It'd be awesome to hear from you and to know if there's anything else that I can help you out with. Other than that, stay hungry, stay classy, make sure that you stay professional, and have a great day.